Another example that we can solve about the problem is z2 plus z plus 2 and z minus 1, z2 minus z plus 1. As you remember, this in the partial fraction you can divide it in the a divided by z minus 1 plus bz plus c divided by z2 minus z plus 1. You can find the coefficient about a, b, c, and this one I didn't calculate it, just easily you can find yourself and compare by this result. Second one, you should know about the z transform of the cosinus theta k or omega theta k or omega ts. Just I write the cosinus theta k, or the answer will be z minus a cosinus theta. Theta you can write the theta is kts, you can put it to, depend about yourself. The denominator will be z2 minus 2 za cosinus theta plus a2, or you can rewrite by the inverse z minus 1 z minus a cosinus theta divided by the 1 minus 2 z minus 1 a cosinus theta plus a2 z minus 2. How can I come here? Denominator multiply by z minus 2, and here will be 1 minus a z minus 1 cosinus theta, and the denominator is the same as here, 1 minus 2 z minus 1 a cosinus theta plus a2 z minus 2. For the sinus will be the same thing. Sinus theta will be z sinus theta, denominator exactly the same as here, or you can rewrite by the z minus 1 sinus theta, denominator will be 1 minus 2 z minus 1 a cosinus theta plus a2 z minus 2. This is the two cosinus and the sinus. Now for the solving this problem, I factorize about the 4z minus 1 from the denominator here and minus 3z from the second sentences. I have now two sentences. This one is easily I can inverse of the z transform, but this one I should a little careful. For these sentences I will write here denominator of here are compared by the standard of the cosinus theta. I write again here, I put a here, write a b, doesn't matter. You find the coefficient about the b, 2b cosinus omega ts will be 1, and the b2 is 1. You can find the b equal to 1. Cosinus omega theta s will become 0.5. If I put here, if you see, numerator will be 1 minus 0.5 z minus 1, denominator become 1 minus z minus 1 plus z minus 2. If you check the standard form and my problem or my solution will have this, I will try the denominator will be separate from this plus another sentences. Okay, this one you know how you separate this one, denominator become these sentences plus another sentences, and as you know, this exactly standard form of mine, a standard form of mine that will become 1k cosinus kp divided by 3. Okay, this one I found. For the sinus, if you remember, the standard form of the sinus will be z minus 1, and the sinus theta here, I put the kts, doesn't matter. Divide by the denominator. Denominator doesn't have any problem. If you put the theta here is a radical, the p divided by 3 become radical 3 divided by 2. And if you compare this one by my problem, you will see the coefficient will not match together. We multiply some coefficient will be match. In the end, you find one part is a cosinus, one part is sinus, and one part is a step. And if you remember the step of the k, step of the will be z minus 1 or 1 minus z minus 1. Then I can find the inverse Laplace of my system. Just only from here to here you should be a little careful. If you have a z minus 1 multiplier of the cosinus, this will be shift your signal by k minus 1. Here I will write about the k minus n, if you remember, will be z minus n x k. Here will be z minus n x k. Here you have the z minus 1. That means all of the system that have a z will be shifted by k minus 1. Here it was 1k. Here will be 1k minus 1. Here become cosinus about the theta or the k. Here k become k minus 1, the same as for the sinus, because for this part. Now the last method, the z transform to solve the different equation. We will see the difference equation can be solved easily using a computer. To compute the computer does not give a closed form expression. The z transform enable us to compute the closed form expression of the solution. The method that take the z transform of the both sides of the difference equation, substitute the initial data, and apply the inverse transform. Is very easy. Consider the example about the uk plus 2, uk plus 1 plus uk. This one we solve together by the initial condition here. Find the closed form solution of these different equations. If I take the z transform of here, this becomes z power 2 u z, and if you remember become minus z to u 0 minus z u 1. The same thing for the here. Then I put the initial condition, the value here, and I find the uz. uz becomes z to minus z minus 1, and easily I can find the two conditions. You can find the first of all, you can divide together, numerator divide by numerator, or directly you can solve the problem. If you factorize about the z of the one of the numerator become here, uz divided by z will be z to minus z minus 1, and here become two sentences, a z minus a 2 z minus a2. You find the a1 and the a2 is easily, you substitute by system. Then you factorize about the z in the denominator here, you multiply z again in the denominator. a1 z minus a, if you remember, a1 is a coefficient become out, z minus a will be a, k will be z minus a, and here for you the a is a1, here is a is a2. you substitute, you find the UF k. Okay. Conclusion, here you find the Z transform play the same role of the Laplace transform